Okay, happy day everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before you go through this particular video, kindly check my former video in which I've explained some concepts as regard to AC circuits. I explained the concept concerning alternating current, direct current, the concept concerning reactance and impedance. I also let us realize that in an AC circuit, only the resistor dissipates power and energy, but inductor and capacitor they do not dissipate power and energy. Therefore, the power for capacitor and inductor in an AC circuit is always equal to zero. So please check my other video to have a full understanding. Then I also derived some formulae connecting the AC circuit parameters. I'm talking about the parameter of capacitor, resistor, and inductor. So we are going to solve a problem now. Let's check this problem. The problem says a series RLC, that means resistor, inductor, capacitor. That is an AC circuit containing resistor, inductors, and capacitor. Has a resistor of 25 ohms, capacitor of 500 microfarad, and inductor of 0.3 ohms. If the current is applied with an alternating source of 120 volts, determine each of these impedance, root mean square value of the current, the phase angle between the current and the voltage. Given that the capacitive reactance is this and the inductive reactance is that. Now, before we start, please take note of this. Capacitive reactance, like I defined in my last video, is the resistance offered by a capacitor in an AC circuit to the AC to the flow of AC current, alternating current I. And this particular capacitive reactance is present with this XC, which is 1 all over omega C. And then, like I said in my last video, omega is 2 pi. This omega is actually 2 pi F. So if I substitute here, my capacitive reactance will now be 1 all over 2 pi FC. Take note of that. Then for the inductive reactance, is the same thing as resistance offered by an inductor in an AC circuit to the flow of AC current, and is given as XL is equal to omega L, which is 2 pi FL, where F is the frequency of the alternating voltage supply in an AC circuit. Take note of that. Now, the question number one says we should find impedance. Like I said in my last video, solution one. Because we are talking about AC circuit that contain resistor, inductor, and capacitor. The reactance Z of RLC is given as square root of XL minus XC. SL is the resistance offered to the free flow of alternating current by an inductor. XC is the resistance offered to the free flow of alternating current by a capacitor. And each of them is known as reactance. So we find their difference and we square them plus R square, where R is the resistance offered by the resistor in an AC circuit. Now, we have been given the value for XL and XC. So Z will now be RLC square root of the XL here. We are given capacitive to be this and inductive to be that. So inductive is 113. Take away the capacitive here is 53.1. That's 53.1 square. Then plus the resistor that we are given there is So we have 25 square. So if we press the calculator, this is a RLC is equal to. If we press our calculator, I believe should be the answer should be, let me see, yeah, 64.9 ohms. 64.9 ohms. So please take note, the inductive reactance, capacitive reactance, and this impedance, their units are in ohms because they offer opposition to the free flow of current. So this is the answer to the impedance containing these elements. Now, the second question says we should find the root mean square value of the current. Now, I just want us to take note of something. If you have something like this, and we have the peak value of the current, let's say this is the current, the peak value is this, there is a particular value called the root mean square value, which we use to convert the value of the AC current to an equivalent value of a DC current. And IP is given as square root of 2 times its root mean square value. Mean square value. So if you're asked to find the root mean square value of this peak current, you divide this peak current by square root of 2. So we have IP divided by root 2. And then we are told that we should determine the impedance, the root mean square value of the current. If you look at this question, if the circuit is supplied with an alternating source of this. Now, I want to let us realize something from Ohm's law. Recall, V is equal to IR according to Ohm's law. But in this case now, the R is the impedance that we just got now. The R is Z. So for this arrangement, V is equal to IZ. And the V here is given as 120 volts. So I put 120 here is equal to I times Z. And the Z that I got, that is the impedance. That's times 64.9. So if you press calculator, we make I subject of the formula. So it's going to be 120 divided by 64.9. 120 divided by 64.9. So it gives us a 1.85 ampere. This value that we get here is the peak value. Now, the relationship between the peak value and the IRMS value is what we have here. So I will substitute the value of this peak value in this formula now. So this one will now become 1.85 is equal to square root of 2 times the root mean square value of the current. So we make the root mean square value of this current the subject of the formula by dividing both sides by square root of 2. So I have 1.85 divided by square root of 2. And then 1.85 divided by square root of 2. So I have a 1.30 ampere as my final answer, or 31 ampere as my root mean square value of recurrence. Now, the next question says we should find the phase angle between the current and the voltage, given that the capacity reactance are all this. So now we know very well that the relationship between all these parameters, I have R here, XL minus XC here, then I have Z here. If you are talking about their equivalent voltage, I can have V for the impedance. Then for this one, it's going to be VL minus VC. Then I have this angle. Then here I have the voltage across the resistor. Now the question says we should find the angle between the current and the voltage, given that the capacity reactance are this and that. Now, if you look at this the current is located along where the resistor is. So the angle between them is this theta. So if I have this one now, I can say tan theta is equal to opposite xl minus xc divided by the hypotenuse. So and then my xl, that is the inductive reactance, is 113. So I have 113, then minus the capacitive reactance is given as 53.1, then divided by the resistance, and the resistance for this particular uh, uh, question is 25. So if we subtract, we are going to have, okay, we take the tan arc of the value that we are having here, and the answer, tan arc of this value that we have here, tan arc of this divided by this, and the answer is 67.3 degree. So that's the phase angle. Thank you so much for listening to my presentation. I believe that you have learned one or two things. Please do not forget to like, share, and subscribe to my video. Have a nice day. Bye.